Semester 4, Unit 8, Polymers, Polymer substances. Well, in our day-to-day life, we use iron and wood. These two materials find extensive use. But there is a problem of iron and wood. Iron gets corroded in atmosphere, so rusting is the biggest headache of using any object which is having made up of iron. There will be effect of weather and germs on wood. For example, in monsoon it swells, and in winter or summer it shrinks. So sometimes it's really creating a lot of problems if we use wood directly. These factors limit the use of such important materials. And the best option available to iron and wood is nowadays polymer. So polymer. Several simple organic molecules of one or two types combine with each other by chemical bonds, forming a macromolecule. The product is called polymer. So polymer is basically organic compound. For example, alkene is one of the monomer. There is a double bond between carbon and carbon. So if we react with second molecule of alkene, it may be ethane also. Then this one valency of carbon should get free. So this will be broken. In fact, pi bond is broken, and so that one valency of these two carbons set free, and this carbon joined with one of this carbon and form a single bond. So it's kind of breaking of pi bond and formation of single bond. Well, the one valency of this carbon still remain free, but when two molecules combine, it is called dimer. When it joins with third molecule, then it is known as trimer. And this way, when n number of molecules combine with each other, they will form a polymer. So the process of formation of polymers from their starting material is called polymerization. Repeating unit. In every polymer, there is a specific repeating unit depending on monomer. This is known as repeating unit. Why? Because same type of molecules recombine with each other. So this will be definitely repeating part. For example, if you take ethylene, then CH2CH2, that is C2H4, is becoming repeating unit. Of course, there will be no double bond in this polymer, but this CH2CH2 structure is considered as repeating unit, and this is polythene. If polymerization of vinyl chloride takes place, then we remove double bond from here so that n number of vinyl chloride molecule can combine with each other and form PVC, polyvinyl chloride, in which CH2 single bond CHCl become repeating unit. So this is the repeating unit. Normally repeating unit is a basic structure of monomer. Degree of polymerization, dP. The number of repeating unit in polymer is called degree of polymerization. Oligomer. When degree of polymerization is less than 25, then it is called oligomer. Heavy polymer. When degree of polymerization is much more, probably greater than 40, then the polymer is called heavy polymer. Classification of polymers. First, classification of polymer based on source. There are three types of polymers: naturally occurring polymer, semi-synthetic polymer, and synthetic polymers. Natural polymers. Some polymers occur in nature. They are known as naturally occurring polymers. Examples: starch, cellulose, protein, nucleic acids, rubber, etc. Cellulose provides food, clothing, and shelter, and rubber provides various articles of daily use. So we can say that cellulose gives us roti, kapda or makan. And it is true. Semi-synthetic polymer. Semi-synthetic polymers are obtained by chemical modification with naturally occurring polymers. For example, cellulose is natural polymer, but if you carry acetylation of cellulose, then OH will be converted into acetate group and it is called cellulose diacetate. Cellulose diacetate is used in making threads, films and glasses. Natural rubber. It is obtained from rubber tree. Well, if you add sulfur on heating, then you will get vulcanized rubber, which will make cross-linking with sulfur. So vulcanized rubber is used in making tires, tubes and etc. Gun cotton, which is cellulose nitrate, is used in making explosives and it is semi-synthetic polymer. Synthetic polymer, which we normally use. A large number of man-made polymers are nowadays available, and these include fibers, plastics, and synthetic rubbers. They find diverse uses as in clothing, electric fitting, eye lenses, substitute for wood and metals, and so many things. Even if you look around, you will find 100 things made up of polymers. Classification of polymers based on reaction. So there are 4 types of polymers: homopolymer, copolymer, addition polymer, and condensation polymers. Homopolymers. Polymers when made by polymerization of single monomeric chemical species are known as homopolymers. Example, if you take ethylene and n number of ethylene compounds combine with each other and form polyethylene, then it is called homopolymer. Here only one monomer is used. Copolymer. When the polymers are synthesized by polymerization of 2 or more than 2 different monomers, they are called copolymers. For example, butadiene and styrene. These two combine and give addition polymer, where you will see the shifting of double bond takes place between second and third carbon. So one valency of these two ends set free, and therefore this CH2 can combine with CH2 by breaking double bond over here, and this way we'll get styrene butadiene rubber. Addition polymers. Polymers when made by addition reactions of many simple organic monomers possessing double bonds are known as addition polymers. Polythene, SBR, etc. For example, in previous one, SBR, styrene butadiene rubber, it is the addition of butadiene and styrene, so it is called addition polymer. Condensation polymers. When condensation polymers are formed by condensation between two monomeric units with the elimination of small molecules such as water, ammonia, alcohol, etc., then it is known as condensation polymer. For example, hexamethylene diamine, which condensed with adipic acid, OH from COOH group, and hydrogen from NH2 is removed as H2O, and this way you will find a long chain like this. This is repeating unit and it is called nylon 6,6. Classification based on molecular force. Elastomers. In elastomers, the polymer chains are held together by weakest intermolecular forces. These weak forces permit the polymer to be stretched. A few cross links are introduced in between the chains, which help the polymer to retreat its original position after the force is released, as in vulcanized rubber. That is called elastomer. Neoprene is one of the monomer. You know, it's like rubber, a rubber band. If you stretch this rubber band, then you can change the length of this rubber. But the moment you leave it, then again it will regain its original conditions and positions or length. That is known as elastomer. Fiber. The polymers which are used for making fibers possess high tensile strength and high modulus. This can be attributed to the strong intermolecular forces like hydrogen bonding. For example, operating polyamide. Look, this is polyamide, in which you will find C double bond O group as well as NH bond. So, when you take more than one nylon threads, then this hydrogen of NH form hydrogen bond with oxygen of CO of another molecule. And this way, you will find strong hydrogen bond between nylon 6,6 molecules. These strong forces also lead to close packing of chains and thus impart crystalline nature. As a result, these polymers show sharp melting points and they are very hard. Thermoplast. You must have observed that there are many plastics. We try to collect it. For example, milk bag. You know, every morning we bring milk at home, and then once we remove the milk, we keep this milk bag with at home only. And when many bags are accumulated, then we will sell it to the other people. And why? The reason is that this milk bag can be recycled. Why? Because they are thermoplastic. So polymers which become soft on heating and regains original state on cooling at ordinary temperature are called thermoplastic polymers. The intermolecular forces of attraction in thermoplastic polymers are intermediate between elastomers and fibers, as for example polythene, PVC, polystyrene, etc. Thermosetting. Polymers which do not soften on heating at high temperature are called thermosetting polymers. Thermosetting polymers, when heated even at high temperature, there are no changes in its structure. Thermosetting polymers are hard and strong and used as better electrical insulators. They are resistant towards scratch. Bakelite and melamines are example of thermosetting polymers. These are like you purchase, you use it and throw it. You cannot recycle it. So you cannot resell those things. Classification of polymers based on structure. For example, linear polymers. Here this is homopolymer made up of only one type of monomer, but when all monomers join to each other in a continuous long chain, it is called linear polymer. Similarly, copolymer. Here different types of monomers are used, but they will combine in a long chain fashion only. So they are called linear polymers. All linear polymers are thermoplastic. That means you can recycle them. Branch polymers. If a long chain formed from monomers containing branching, it is called branch-tailed polymers. Their properties are somewhat similar to linear polymers, but due to branch polymer structure, they remain in solid state even at high temperature. Therefore, they can be called thermosetting polymers. PVC, polystyrene, Teflon, etc. These are branch polymers. Crosslink polymers, bifunctional or trifunctional monomers. That means those compounds which have more than one functional groups combine with covalent bond in between the long chain. Such polymers are known as crosslink polymers. Crosslink polymers do not soften even on heating at high temperature. So these polymers are compact, solid, hard and resistant to abrasion, and they are thermosetting. Examples: bakelite and melamine. Now, classification of polymers based on growth and polymerization reaction. We'll take addition reactions. Addition polymerization or chain growth polymer. When large number of monomers of one or two types, when large number of monomers of one or two types possessing one or more double bonds combine with each other by chemical bonds to form a polymer, then that reaction is called addition polymer. The addition polymerization is carried out with monomers like ethene, propene, styrene, 1,3-butadiene, isobutylene, etc. When large number of two types of different monomers possessing double bonds combine alternately with each other by chemical bonds to form polymer, then that reaction is called addition copolymerization. Styrene butadiene rubber (SBR) obtained from styrene and butadiene monomers is copolymer substance. The addition polymerization is also known as chain growth polymerization. The addition reaction is carried out through the formation of reactive intermediates like free radical carbocation or carbanion. Let us see mechanism. Free radical addition. This is tertiary butyl peroxide. Homolysis of tertiary butyl peroxide takes place. These two oxygen will be separated, and now we have tertiary butoxide radical. This is having free electrons, so it is called free radical, and this is chain initiator. It starts polymerization, therefore it is called chain initiator. Second step, chain initiator like ion dot will react with monomer which is having double bond like ethylene. Now in this case homolysis of pi bond takes place. This electron will shift to the original carbon. So when this electron transfer to this carbon, it has one free electron and one less bond. So this CH2 can combine with IN with these electrons, and therefore there will be covalent bond between IN and CH2. But when this electron will shift to another carbon, these ends remain free. So new free radical form. Then this second ethylene group again with homolysis produce two carbon free radical. Out of this, one of these will join with this carbon and form dimer, and with one free radical. So this way n number of ethene combine with each other and form a long chain. This is called chain propagating step. Now the last step, which is called chain terminating step. Now we have to stop this reaction. So we take two long chain like this, which is having end free. So these two free ends combine with each other and form a long stable polymer, and it is linear polymer, polythene. So this is free radical mechanism. Now cationic addition mechanism. Ha means acid, which ionize to give H plus and A minus. These H plus of acid react with one of the alkene. In this case, two electrons of pi bond will shift to end carbon. This is heterolysis. Like isobutylene, where CH2 receive these two electrons, and therefore this carbon become negative ion. Now this will attract H plus and form a bond. So this is called chain initiation step, and a carbon positive ion is produced. So here carbocation is produced. Okay. Now this will again react with the same molecule. Same heterolysis takes place. This 2 pi electron will shift to CH2. So this CH2 is having extra pair of electron, which will combine with the C plus and form a covalent bond. But simultaneously, these carbon carry positive charge. So this way, positive charge will shift to new molecule, and the the length of the chain increases. It is known as chain propagating step. The last one, in which this is a long chain of carbocation chain. Here, this A minus of negative acid, which will take hydrogen from this CH2 and form HA. So when H plus is removed from CH2, again electron pair appear on this carbon with one less hydrogen. So that electron pair will form double bond with this carbon and positive charge is removed. So this way finally we get butyl rubber polymer, which is having one double bond. Anionic addition mechanism. Potassium amide is one of the initiator. If it reacts with styrene, for example, hydrolysis of pi bond takes place. These two electrons will shift to CH, and therefore this CH2 carry positive charge. So this NH2 will combine with CH2 and this CH carry negative charge. This is called chain initiation step. So now this styrene molecule will combine, n number of styrene can combine in, and that is chain propagating step, and you will get huge chain. But at the end you will find carbon anion at the end with styrene. The last step is chain terminating step, where H plus will combine with CH and form CH2. So this will remove negative charge of carbon and will get stable polymer. It is called polystyrene, and this is anionic mechanism.